Add it up.
Add it up.
Well, good morning. Happy Saturday. I hope you guys are doing well. Happy Saturday. If you don't have your coffee, go get your coffee. It is Saturday morning and it is early for a lot of you. However, we are here to study for the Comptia Data Plus exam. This is the DA001 study group. Thank you guys so much for coming out and chilling and hanging out as we go through the study material. We are finishing up the LinkedIn Learning portion right now. Once we get done with that, we will move over to the bookwork and we will start the study for that. Just a couple of just housekeeping things. So this course runs so we don't just go the whole entire hour without stopping. So just be aware of that. We go 45 minutes. Once we get done with that, you'll have a 5-minute break. You get up, walk around, get your coffee, water, go to the bathroom, that type of thing. Once we get done with that, we come back. We have another just 5-minute recap, and then we end. So this runs for about an hour. It is 8 o'clock Central Standard Time. We'll be running until 9. So let's go ahead and get started. And we're on visualization work now.
Data warehouse that updates every night. Whenever you access a dashboard drawing from this data warehouse, the data will be current as of the previous night. Continuous data, also known as live data, typically comes directly from an operational database that people use to perform their daily duties. The operational database provides a live data feed to the dashboard, and the data in the dashboard is then always current in real time. Using this continuous data is more costly, however, because you have to design robust operational databases that can support operational needs and reporting needs at the same time. You'll work with two different types of information on your dashboards. Dimensions are attributes that you use to divide your data into categories or segments. Use data field definitions to create dimensions that most accurately meet the organization's reporting needs. For example, you might want to create dimensions for geographic regions, departments, or other categories that are meaningful to your organization. Measures are numeric, quantitative values that a dashboard user can explore. For example, a sales executive may wish to examine regional sales of a specific product over time. In that case, the number and dollar value of sales are measures, while region and time are dimensions. When you take the Data Plus exam, remember that a measure contains the data that a user wants to analyze, while a dimension provides a way to segment or subdivide that data. After you identify the data sources that will power your dashboard, you can turn your attention to developing the dashboard itself. You can use wireframes and mockups to help build and refine the dashboard's design.
Usually you'll probably use
A
like Tableau
wireframe is a
or
blueprint for an
something
application that
like
defines the
that.
basic design and function of the dashboard.
That's how
Think of
you
a
make
wireframe like the
an
blueprint
app, an
for a
iPhone
building.
app, and do a
Architects
wireframe
develop
for it.
blueprints to describe the internal structure of a building, and wireframes define the basic structure, functionality, and content of a dashboard. You can use wireframes to define the presentation layout and navigation flow and guide how people will interact with your dashboard. Wireframes allow you to plan the story that you're going to tell with your dashboard. A mockup extends a wireframe by providing details about the visual elements of the dashboard, including fonts, colors, logos, graphics, and page styles. While a wireframe is conceptually similar to a blueprint, a mockup is closer to an architectural rendering. The goal of a mockup is to give people a perspective about the dashboard's final user interface. You can use mockups to ensure that your dashboard is consistent with your organization's communication standards. As you develop your dashboard, keep the story that you want to tell with the data in mind. For example, data story planning often begins with aggregated data that answers straightforward questions like, how many people work here? Now, while the answer to that question is a number, you should anticipate follow-on questions, such as, how many women work in leadership roles? Or, what's the average tenure and age distribution of our workforce? Anticipating the answers to these questions can help you design an optimal web interface. Now, keep in mind that creating a dashboard is an iterative process. As you develop wireframes and mockups,
Iterative
be sure that you
process, that is
deliberately
true.
incorporate steps to obtain approval to proceed. One way to ensure that you don't lose sight of crucial requirements is to include the voice of the customer during feedback sessions. In these sessions, show your mockups to the people who will be using your dashboard. Most often, people think of additional features and voice new requirements when they're reacting to the design of a mockup. Document and incorporate this feedback to improve the quality and usefulness of your dashboard. Then, at the end of the development process, the goal is to have a dashboard that informs and delights its users. Once you have final approval, you can then proceed with developing the dashboard. Similar to the design stage, make sure that you include frequent opportunities to gather feedback. Once dashboard development is complete, test the dashboard thoroughly to make sure it works properly. As you build your dashboard, make sure that you clearly define the access permissions for that dashboard. Access permissions limit the data that any person can access. When you define these permissions, you should do that using roles instead of the names of individual people. Create an access role for each type of user who needs to access the dashboard, and then assign people in those jobs to that role. This role-based access control requires a little more work up front, but it saves you a ton of time down the road as people change positions and enter and leave the organization. After the dashboard is in active use, your work is not over, however. You need to ensure that the dashboard continues to answer leadership's questions while performing well. As the person responsible for the dashboard itself, you need to pursue ongoing dashboard optimizations. These enhancements may improve the performance of a dashboard component, or they may include a new data source to enable answering new sets of questions. Once you have a dashboard in place, you should think through how you will deliver the dashboard's contents to its users. You may choose to use a subscription capability where people can opt in and receive notifications when the underlying data changes and the dashboard is refreshed. In addition to offering a subscription service, you may choose to offer scheduled delivery, where users receive scheduled copies of information from the dashboard that's relevant to their work at the time that they need it. Dashboards also normally have interactive capabilities that allow users to explore data in different ways. One of these capabilities is the ability to drill down into the data. This allows users to click on aggregated data points and break those data points out into their component parts. For example, suppose the dashboard landing page for a chief sales officer shows total corporate global sales. The CSO may want to see more detail for a given region, county, or metropolitan area. When they drill down into a specific region, the dashboard filters the data to only show the details for that region. Similarly, if they further drill down into a country, the dashboard would only show the sales data for that country. Dashboards also allow
Tableau
us to
works
perform
really
the
well
opposite
for this, or at
operation
least
and roll
right
up
now,
data.
the
Rolling up
experience
data
that
allows
I
us to
have
move
is
from
working
low-level
with
details and
Tableau
view the bigger picture
for
by
my
aggregating
visualizations.
data. Rolling up data is the opposite activity of drilling down into data.
No, you
Finally,
don't
as
have to
users of your
just
dashboard
use
navigate through
Tableau.
datasets, filtering and aggregating data,
I
they
just
often
think it's
develop
visually
views
very
of the data
pretty.
that are useful to them. Many dashboarding platforms allow users to create saved searches that remember these filters so that users can easily apply them to new data at a later time.
I'm sure he'll have like some type of questions about or suggestions as to what to use for visualization. I can actually see what he has in the coursework that's coming up. So he's just talking about charts, not necessarily the specific. So I'll show you what Tableau is here in a minute, or I'll show you when we get to that 5 minute. Just remind me later on. All right, so you are looking at a dashboard of sales by U.S. states and would like to see the sales for individual counties within a specific state. What action should you take? Drill down to your specific state. What type of metric is commonly shown on dashboards to assist senior leaders in assessing the organization's progress towards significant goals? What is KPIs? You are creating a dashboard that shows the total revenue for your organization broken out by a variety of factors. Which one of these is a measure rather than a dimension? This was in the beginning. Geographic region. Then I'm going to go revenue as the next option. Okay, so which one is a measure? Revenue measures money or the money that's brought in by the company. What type of access permission system is most appropriate for a dashboard? I'm going to go role based. That way it's set up according to who's coming in.
As a data professional, you're going to often need to create data visualizations that help convey the story of your data to your audience. It's often a lot easier to let a data visualization convey insight to your users than to try to communicate using raw data or even descriptive statistics. Line charts are one of the most common mechanisms for conveying information about data in a visual format. Line charts compare the values of two variables using two different axes. You can place any variable on any axis, but the most common approach is to place time on the x-axis and another variable of interest on the y-axis. This approach allows you to create a natural-looking visualization where time proceeds from left to right. That's the normal way that people expect to see data on a line chart. Here's an example of some data gathered about the temperature inside a piece of industrial machinery. Now, we're just looking at this data in spreadsheet form, and it's a little difficult for our minds to make sense of this. Sure, we can see some cases where the temperature seems to get higher, but it's hard to identify what trends exist in this data. Now, if we place this data on a line chart, it becomes very easy to identify trends in the data. And in fact, we can see that the temperature inside this equipment seems to be spiking at the same time every day. That's useful information and something we'd probably want to share with the people responsible for operating and maintaining this equipment. That's a great example of how data visualization can provide us with useful information. In cases where you want to compare two variables, but you aren't using time or attempting to see a trend, a scatter plot might be a better choice. Like line charts, scatter plots have two axes, an x-axis and a y-axis. Each of these axes can be used to represent any numeric value. You can choose to plot whatever you'd like to compare. Then, instead of drawing a line to represent your data, you use dots to represent each one of the points in your dataset. For example, here's a scatter plot showing information for colleges in the state of Indiana. This plot includes two different variables, tuition and average SAT test scores. Each dot on the scatter plot represents a single college, and we can see from the placement of each dot the tuition rate and SAT score at that institution. When we look at this chart, we can see some interesting things here. For example, we see two separate groups of colleges, and I might want to modify my chart to explain that difference. I can do that by bringing in another variable, whether the college is public or private. Here's another version of the chart where I've done just that. Now we have different colors
See, like
representing
what he
public
just
schools
did
and private
there. Hold
schools,
on,
better
I'll just
explaining the
pause this
data.
real quick. So what he just did there, this is something like this little control portion on the right. That's stuff that you do in like Tableau, where you create different colors of your legend so that you can show, in this case, like he did with the SAT averages versus the tuition. And you can go in and change the colors to help the end user be able to see, well, why do these dots matter?
Bubble charts are very similar to scatter plots, but the major difference is that in a scatter plot, all of the dots are the same size, but in a bubble chart, the size of each dot represents another variable. For example, here's a scatter plot of tuition and test scores at the private colleges of Indiana. If I also want to incorporate the number of students at each school, I could turn this into a bubble chart where the size of each bubble is proportional to the number of students at each school. Pie charts are another common visualization technique. They take their name from the idea that you can take a pie and slice it up into pieces of different sizes. In a pie chart, we can show the proportions of different variable values as they relate to the whole. We're describing a single variable, and then each wedge of the pie represents one value of that variable. The percentages of all of the wedges in the pie will add up to 100%, which is a full circle. Here's an example of a pie chart for a variable that has only two possible values. It's showing us the percentage of colleges in the United States that are under public control and those that are under private control. Now, we can see here that there are more private colleges than public colleges, and we get a sense that it's only slightly more, but it's easier to read if we add percentage labels to the pie chart. We can create pie charts for variables with any number of values. Here's one that shows the colleges by region of the United States with 4 possible values, and once again, it's easier to interpret this chart if we label each wedge with the appropriate percentage. When you're designing a pie chart, it's generally a good idea to keep the number of wedges to a reasonable amount. Here's an example of a pie chart that tries to show the percentage of schools in each of the 50 US states. This is basically impossible to read. Bar charts are another common visualization tool that we use to show how data fits into different categories. Like pie charts, basic bar charts show a single variable and then use different bars to represent each possible value of that
They're
variable.
usually different
The
colors
x
too.
axis of a bar chart contains all of the possible values for the variable, and the y axis is the count of the number of instances of each value. In the previous video, I showed you a pie chart that demonstrated the proportion of colleges in the US that are public and those that are private. Here's a bar chart showing that same comparison. Similarly, we looked at a pie chart showing the division of schools among 4 geographic regions. Here's that same data on a bar chart. Now, people often prefer bar charts to pie charts because they tend to be a little easier to visually interpret. Stacked bar charts allow us to add a second variable to the mix by dividing up each bar into segments, with the size of each segment representing the proportions of the values of the second variable. For example, here's that chart of schools by region again. If I wanted to show the proportion of schools in each region that are public and private, I could transform the bar chart into a stacked bar chart and have different segments.
Okay, so again, this is an area, this is something you do in Tableau. I recognize these boxes, these back boxes here, and the control portion that he's putting that he's putting here for his dashboard. You could do that in Tableau very easily, and these color schemes that he's using are not random. Actually, in Tableau, you can go in and choose specific color palettes. So yes, it is possible to do this in like Excel. Yes, you have a good point, but like Tableau, it pulls this information. The difference is in Excel, that information is very static. So because that information is very static, like in this would be connected to a data set, and then that data set you will have pulled from some system. So from some via SQL, you will have pulled it from some database. So let's say that something changed in that database. well, your dashboard here would change. In Excel, that's not the same, because in Excel, you're not going to, that's more static information. So if you were just giving someone, you wanted to give them a quick study of something, then you could use Excel to do. But yes, you can do the same visualization in Excel, but they are different, Tableau and Excel, and what they do specifically, but in the way that they visualize things differently.
On each bar showing that division. Histograms look very similar to bar charts, but with one important difference. Histograms allow you to create bars for variables that have numeric rather than categorical values. They do this by creating bins that group similar values together. Let me show you an example so you understand why that's necessary. Suppose that we wanted to know how schools in the US vary by the tuition that they charge. Here's what I get if I try to make a bar chart. There are hundreds of schools, and many of them charge slightly different tuition values. Each unique value gets its own bar, and this is pretty much impossible to read.
And useless
If
to
I
the
use
end
a
user.
histogram instead, here's what I get. Now, the tuitions have been grouped into bins, making this data much easier to interpret. When I build a histogram, I get to choose the number of bins, and this decision determines how granular my data is and what trends I'm going to be able to see.
Exactly.
For example, these three charts show the same tuition data. The only difference is that the chart on the left uses 10 bins, the chart in the middle uses 20 bins, and the chart on the right uses 30 bins. Waterfall charts are an interesting type of visualization that allows you to break down the ways that a variable changed over time. They start with a bar that shows the value of a variable at the beginning of a time period, and
I don't
end with
think
a
I
bar
have ever
showing the
set
value
up
of
a
that variable
waterfall
at the
chart
end of the
yet.
time period. They then
Not
use a
even
series
in
of
the
bars in
classes that I
between to
took. I
show the
know of a
factors that
waterfall chart,
contributed to
but
the
I don't
change
think we
over
set one
time.
up.
The bars are typically colored, and it's common to use green to show causes of increases and red to show causes of decreases. Here's an example of a waterfall chart that explains how the number of employees in an organization changed over the course of a year. The company started the year with 343 employees and ended the year with 361 employees. Now, if that's all you'd say, okay, this organization grew by 18 employees. But there's much more to the story that we can show on a waterfall chart. The reality is that the organization made a series of hires that increased headcount, but then some of those hires were internal moves, and there were some voluntary and involuntary separations that contributed to the new number. The waterfall chart gives managers much more insight into how staff changed over the year than they get from a simple bar or line chart that only showed the beginning and ending
Okay, that
values.
makes sense.
Heat
No, I've never
maps
had
are
to
a
do one
special
of
type of
those. And I've never
visualization
had
that
to
you
do a
can
heat
use
map
when you have
yet
two
either.
categorical variables and one continuous variable that you'd like to visualize. A heat map places the two categorical variables on the x and y axes, which creates a grid of boxes. Then we use color to show the level of intensity of the continuous variable by coloring each one of those boxes. Here's an example of a heat map from the college dataset. We have the region of the country on the x-axis, the highest degree granted by each school on the y-axis, and then the color represents the average tuition at schools in each category.
And why would
Looking
you
at
do
this
this?
chart, we can quickly see that the schools that grant higher degrees tend to be more expensive than those that do not. We also clearly see one anomaly that we'd want to investigate. Schools in the West region that grant bachelor's degrees seem to charge much higher average tuition than any other group of schools. That's the type of analysis that heat maps excel at, allowing us to pick out unusual situations for further analysis.
Interesting.
Sometimes we can build an interesting analysis by incorporating geographic maps into our analyses. This is especially
In the
helpful when the
class
consumers of
that,
our analysis are
if
familiar with the
you
geographic region.
you guys were asking about the class the last time, like offline, the class that I took, it is actually a class on Udemy. It's a really good class on understanding like Tableau, and really, I did a couple of things which are on my website. You can look those things up. Like I did projects, and the first time that I built an actual dashboard, it was nothing major, but it was the first time I built it after going through that class to really understand that there was, that I was actually doing something, that's priceless. So, and one of the things that you build is you build out specific sections, so like of the United States. And for those of you that are out of the country, of course you know the United States, but what you would be able to do is hover over a specific area, and it was a data set for like census based off of specific, first it was specific states, then we had to even drill it down more than that to get to specific cities that we had data. So it took us a while to do that, but that was one of the things that we did. We weren't able to. That one's actually on my Tableau Public. I don't think I put that one on the website, but that's on the Tableau Public. Again, you can look for my name in Tableau, then you can see that work as well.
Region in question. Here's an example of how we can combine the concept of heat maps with geographic maps to better communicate.
And you do
This
this
map of the
often. This
United
part
States
you do
color
often. I
codes
just never
each
seen
state
it
in
done
different
separate
shades of
in its own
orange
chart.
to show the number of schools in each state. Now, if you're familiar with the geography of the United States, it's very easy to see here that states like Pennsylvania, New York, Texas, and California have a large number of colleges, while states with lower populations like Wyoming and Nevada have very few colleges. Nested data is data that has both categories and subcategories. When we're analyzing nested data, we often want to be able to see both of these groupings, and it's pretty difficult to do that with most visualization techniques. Tree maps are a special kind of visualization designed specifically for nested datasets. They work by creating a series of boxes for each of the categories of a dataset, and then dividing those boxes into smaller boxes for subcategories.
Like a
The
mind
size
map?
of each box represents the proportion of the whole for that subcategory, similar to the way that a pie chart works. The subcategories of each category use similar colors so that it's easy to tell them apart and group them together. Now, it's easier to understand tree maps if we use an example. Here's a tree map of the US federal budget for 2016. This shows some major categories such as healthcare, national defense, income security, and social security. We can see from looking at this chart that the largest category of expense here is healthcare. Inside the healthcare box, we can see smaller red boxes that show the components of the healthcare expenditures. It looks
Okay.
like half the money we spend on healthcare is for Medicare, and most of the rest is for Medicaid. A heat map like this one makes it easier to explore a data set and understand the relationships between different categories of
Okay,
nested
I got
data.
it. They should have. I would have made
We
the
often have
header
quite a bit of
colors
data in
different,
text
but
form that can be difficult to analyze because it doesn't fit into the mold of tabular data that we're used to encountering. Word clouds are a simple way that we can perform some analysis on text.
oh, you
Word
gotta
clouds
love
look at large
his use
quantities of text
of
and tell us what words appear most often in that text by using larger font
he'll
sizes to
pull
represent
these aren't
words that
like
appear more
specific
often.
things that he's doing. Like if he doesn't
For
have something, he'll
example,
pull in
here's a
like
word
this word
cloud
map.
generated from the text of the US Declaration of Independence. You
Oh,
can
okay,
quickly
that's kind
see
of
some
cool.
themes in the text by looking at the largest words here: people, laws, government, states, and rights. Infographics are another tool commonly
One of my
used to convey the
favorites.
results of data
Really
analysis to
love
readers. They
infographics.
combine data points, text, and visualizations to help quickly tell a story in an appealing way. Here's an example of an infographic put out by Bill Gates that poses an intriguing question. What is the world's deadliest animal? When you look at the details of the story told here, you find a surprising conclusion. Mosquitoes kill more people than any other animal, including humans ourselves. This infographic combines images, visualizations, and
Hmm.
data to make that point in a very compelling manner.
All right. What are our questions for this one? When building a word cloud, what feature varies with the frequency that a word appears in the text? I'm going to go font size. Where would you show time on a standard line chart? That is going to be on the x-axis. What feature varies on a bubble chart but not on a scatter plot? Size of the bubble. How many variables may be shown on a single pie chart? On a single pie chart, it could, I would say 4, because that's, oh no, okay. So then 2? Interesting. So it's one variable that can be shown on a single pie chart. Okay, and then you break that down. What type of visualization allows the use of bar charts for continuous variables? Bar chart for continuous variables. Histogram? All right. What colors are commonly used for the change bars in the waterfall chart? Red and green? How many variables are normally shown on a standard heat map? Maybe this is one variable too, and okay, then I don't know that. So it's definitely not 1 and 4. So the correct answer was 3 variables are shown. Okay, 3 variables. What type of data is best suited for displaying using a tree map? Nested data. 7 out of 8. Let's move on.
After you complete your data analysis and create some beautiful visualizations, you're still going to need to present the results of your work to your stakeholders. That's the crucial moment for any data analysis effort. If you're trying to use data to make informed business decisions, you need to effectively communicate the results of your analysis to those decision makers. In many cases, you'll do this in the form of a report. Let's talk about a few of the different ways that we can categorize those reports. First, we can divide reports into 2 categories based upon the data that they draw from. Static reports are created at a single point in time and reflect the data that was current at the time of the analysis. If you've ever read a report in PDF form, that's an example of a static report. If I create a static report today and provide it to you, that report will be the same today, tomorrow, next month, and next year. The static report will always be based upon the data that I analyzed today because static reports don't change. Dynamic reports, on the other hand, change with the data. They're designed so that they always pull in current real-time data and they're updated as the data changes. We often publish dynamic reports through websites. Users can then visit the website and view that dynamic report whenever they want to. The report that they view today will be based on today's data, and the report that they view tomorrow will be based upon tomorrow's data. Dynamic reports change. We can also describe reports based upon how often they're generated. Recurring reports are generated on a planned frequency. Users might receive the same report every day,
Hence the
once a
term
week, at
recurring.
the end of every month, or in some other scheduled interval. For
Not
example,
trying to be
managers
smart
might
about
want to
it, but
receive
it's
a
like
weekly
hence the
report of all
term
of the sales
recurring.
at a retail store. That report would have the same format every week, and report developers can set it up to run automatically every Sunday morning. Other reports might be created on a one-time or ad hoc basis. This just means that they're not intended to be created over and over again. Reports like this are normally meant to answer a one-off question. For example, a company considering an early retirement plan might want to know how many employees would be affected and ask a report writer in human resources to generate a report showing the number of employees in each department that would be eligible for the plan. They'll use that report to make the decision whether to offer the plan and then never use that report again. It's a one-time report. Reports may
One-time
be
report.
created for tactical or strategic purposes. Tactical reports provide information to inform an organization's short-term decisions. Tactical information helps organization accomplish initiatives like constructing a building, opening a manufacturing plant, or shipping products from one location to another. The data for tactical reports comes from various sources, including operational and analytical systems, and these reports enable operational decisions. Research reports help an organization make strategic decisions. While tactical reports inform a decision with limited scope and duration, research reports inform the development of a broader strategy for the organization with significant impact. These research reports might assist with deciding whether or not to acquire a competitor, select a supplier, or enter a new market. These research reports have very significant possible consequences, so they generally take much longer to create than tactical reports. Strategic research reports often combine internal data about an organization's operational performance and risks with external data about external forces. As we wrap up our discussion of reporting, let's talk about some examples of the reasons that you might generate reports. Many organizations are subject
You
to a
said
variety
to
of
maybe they
regulatory
need to open
compliance
a
requirements.
building.
These might be related to
Maybe
health,
there's,
safety, financial reporting, or
yeah,
other
safety would be
obligations.
one I
When
could see.
managers want to ensure compliance with these regulatory requirements, they often use reports to track their obligations. Reports are also very useful in the operational management of an organization. Managers can use reports to track the organization's key performance indicators, or KPIs, and ensure that the organization remains on track to meet its goals. Managers also use reports to monitor risks facing the organization. These might be strategic, operational, financial, reputational, or other risks, and reporting can help monitor and manage them.
All right, we have just one question in this one. What type of report is commonly used to make operational decisions? He called tactical is operational decisions. I'm assuming, okay, then it's not tactical. I guess it, what? Okay, so it is tactical. Okay.
Thanks for watching my Comptia Data Plus data visualization course. It's been a pleasure joining you for this journey through the world of reporting and dashboards. Now, I hope that as you've completed this course, you found it interesting and helpful in preparing for the Data Plus exam. You should now have a solid foundation for the data visualization domain of that test. If you're following my Data Plus course series in order, you should now turn to the Data Plus Governance, Quality, and Controls course. Otherwise, you can move on to any of the other 5 courses in this series. Good luck with the rest of your test preparation.
All right. So as usual, we are going to download our certificate. Make sure that all of that content goes. We are gonna we're gonna add it to where we need, but I do need to make sure, where's my actual certificate at? All right. So yes, I do download these. I do keep them so that I have them just in case anything ever happened to LinkedIn. We've already done the post. I'll put the stuff on there later on. We are going to go back and go to what will be our final section. We have about 10 minutes, so we probably won't make it through this full thing, but we're going to go through
Governance and quality controls are crucial to the success of modern information-driven organizations. They help ensure that data is accurate, timely, valid, consistent, and unique. Hi, I'm Mike Chapple, and I'd like to invite you to watch my course on data governance, quality, and controls. It's part of a 6-course series preparing you for the Data Plus exam. I hope that you'll join me as we explore the world of data governance. I've designed this series of Data Plus courses with the beginner in mind. While you'll probably find it a little easier to complete this course and the Data Plus certification if you have a background in the field, that's not a requirement. If you're looking to get started in data analytics, this course series will provide you with all of the information that you need. If you're an analytics professional with some working experience under your belt, this course series will help you fill in any gaps in your knowledge and build a solid foundation as you prepare to take the Data Plus exam. Managing data is a complex undertaking that requires collaboration across the entire organization. The work of collecting, preserving, securing, and maintaining data doesn't fit neatly into our traditional organizational structures. Consider, for example, the human resources data collected by your own organization. You probably have a pretty significant amount of information about your employees collected from their job applications, new hire paperwork, performance management processes, computer activity, and many other sources. Well, who's responsible for that data? It is human resources data, so it probably makes sense for the human resources department to have overall responsibility for the data, but they can't possibly do it alone. Think about the other groups involved in collecting and handling this information. The information technology team certainly plays an important role. They design, implement, and manage the systems that store this data. The information security team plays a role in protecting the confidentiality, integrity, and availability of that data. Your legal team helps the organization understand the legal and regulatory requirements around processing that data. You may have a data analytics team that also helps protect the quality of the data and helps business leaders use the data to make decisions. And the list may go on and on. Balancing all of these diverse interests is the main reason that organizations develop data governance programs that try to clearly outline the lines of authority and responsibility for data management. In a data governance program, the organization typically designates a senior leader as the data owner for a particular topic area of data. In the example of our Human Resources Department, the Vice President of Human Resources might be designated as the data owner for employee data. The data owner has ultimate authority over the data, but the nature of their role as a senior leader means that they probably don't have the time or knowledge required to make day-to-day decisions. For this reason, data owners designate a series of data stewards to help carry out their data responsibilities. Data stewardship programs take their name from this designation, and they help ensure that the organization has a clear and consistent process for making decisions about its data. Now, the general term stewardship means a job of supervising or taking care of something, such as an organization or property. And that's exactly what's happening in the world of data stewardship. The organization's data stewards are responsible for taking care of the organization's data. As we work our way through this course, we'll explore the roles and responsibilities of data stewards in more detail, but this high-level description will always be our guiding principle. Data stewards take care of the organization's data.
Well, he said that
Data
twice.
governance is a complex problem,
somewhere
and
in
many
here
different
there's
people
a
throughout
past
the
question has
organization
to do
play a
with data
role.
stewardship.
Let's take a look at some of the concepts surrounding data ownership and stewardship, as well as security and privacy. Data controllers are the entities who determine the reasons for processing personal information and direct the methods of processing that data. This term is used primarily in European law, and it serves as a substitute for the term data owner to avoid a presumption that anyone who collects data has an ownership interest in that data. Data processors are service providers who process personal information on behalf of a data controller. For example, a credit card processing service might be a data processor for a retailer. The retailer retains responsibility as the data controller, but uses the service as a data processor. Within these two types of organizations, individuals often hold varying roles based upon their responsibilities. We often think of these roles as fitting into a three-tiered model. At the highest level, the data owner for a particular data set is a senior-level official who bears overall responsibility for that data. The data owner sets policies and guidelines around data use and data security and has the authority to make final decisions regarding the datasets under their control. Data owners are usually business leaders who have responsibility for the mission area most closely related to the dataset. In the example I gave earlier in this course, an organization's vice president for human resources might be the data owner for employment information. Practically speaking, most individuals who are senior enough to hold the position of data
we're
owner
almost to
don't have the
our
time
5-minute
available to get
break.
involved
You
in the
can see the
nitty-gritty
time in the
decisions of
right-hand
data
corner.
governance, and they usually delegate
So
that
very
responsibility
soon,
to a data
this is going to
steward.
stop. We're
The
going to
data
go to
steward
break
handles the
and,
implementation of the
stand
high-level
up,
policies
please,
set
get you
by the
some
data
water, that
owner.
type of thing.
For
I just
example,
wanted
a
to give
data
you a heads
steward
up.
might make day-to-day decisions about who may access the dataset. In the case of an employee dataset, if the data owner is the vice president for human resources, that vice president might delegate data stewardship responsibility to a director for HR information services. In most cases, there is a reporting relationship between the data owner and the data steward. Data custodians are the individuals who actually store and process the information in question. Information technology teams often find themselves in the position of data custodian because of their roles as system owners and administrators. Technologists are rarely data owners or data stewards, but they are often data custodians for almost all of the data in the organization due to the nature of their jobs. Data custodians ensure that appropriate data protections are in place, including encryption, backups, access controls, and other mechanisms that meet the requirements set forth by data owners and data stewards. In addition to security, data owners have a responsibility to ensure that the organization fulfills its privacy requirements. These requirements may come from legal, contractual, or ethical obligations. For example, if an organization stores the social security numbers of employees, the data owner should make sure that those numbers are properly protected and only used for legitimate business purposes. Organizations subject to the European Union's General Data Protection Regulation, GDPR, are required to formally identify a specific individual who is responsible for data protection. This person is known as the Data Protection Officer, or DPO, and has specific responsibilities under European law. GDPR also requires that the organization grant the DPO the authority to carry out their responsibilities free from intrusion by management.
I wonder, do we have a version
Serving
of
as a
that in the
data
United
steward is a
States?
challenging role. Data stewards need to have a strong understanding of their organizations, the subject matter domain over which they will have stewardship responsibilities, and the different areas of data stewardship responsibility. Let's take a moment to talk about the qualities that make a good data steward. First, a good data steward is a relationship builder. Data stewards often find themselves in difficult situations where they're being forced to balance competing demands or even say no to requests from different parts of the organization. These difficult conversations go much better when the data steward has strong working relationships throughout the organization. They have the trust of colleagues from around the organization and a network of pre-existing relationships to rely upon when they have to make those tough calls. Along those same lines, a good data steward is collaborative. It's true that data stewards have a lot of authority and discretion in how they carry out their work,
All
but
right,
the
less than
best
a
data
minute for our
stewards aren't
break.
authoritarians who simply lay down the law. Strong data stewards work closely with others in the organization to collaboratively reach solutions to challenges that are in the best interests of the entire organization. Now, unfortunately, it's not always possible to reach a consensus on some of the thornier issues surrounding data access, security, privacy, and related issues. For this reason, good data stewards are also influential, respected members of the organization. When they have to make those tough calls, they have both the formal authority and the informal influence to make their views known and drive the organization toward achieving their objectives. Serving as a data steward also requires subject matter expertise. Others in the organization will look to the data steward to have a thorough understanding of their functional area and be able to apply that functional knowledge in the context of data decisions. For example, you would.
All right, so enjoy your break, 5 minutes. All right, welcome back. I hope you enjoyed your break, and let's go ahead and get started. We have just about 5 minutes left.
Want to have a data steward covering human resources data who doesn't understand human resources practices. Finally, data stewards also must have an understanding of the principles of data governance. While many organizations consider data management a technical activity, the reality is that it's a hybrid function where technologists and subject matter experts have to work together. Good data stewards serve as the bridge between these worlds, bringing together technical and functional experts and helping each understand the other's concerns. Earlier, I summed up the responsibilities of a data steward as taking care of the organization's data. Now, that's a reasonable description of the role, but it's also pretty high level. What does it actually mean to take care of the organization's data? Well, data stewardship responsibilities may vary from organization to organization, but we can summarize them as fitting into 4 general categories: data quality, data security, data privacy, and regulatory compliance. Data
Okay,
quality
before we
ensures that
continue this part, since we have such a short period of time, we'll leave that for our next meeting. And what we want to do, what I want to do really quickly is to take you to, if you have never, so it's some of you are asking about Tableau. So Tableau is, they do have a portion for students, so just be aware of that. Is the Tableau conference is coming up? That's going to be awesome too. I wish I could go, but as an analyst, then they have things that they have this community. I will say that much. They have, Tableau has a community that is like, it's like an Apple thing. If that makes sense to you, they are really dedicated to the craft of visualizing data. So there is a version now. The class that I took that I wanted to tell you guys about was on Udemy, like I was showing you, and it was a class that I took. I don't know if I purchased a class or I don't even remember how I really honestly which way I took the class. I just remember taking it and then going like, I really enjoyed this class. This class right here. So if you were looking at anything and you wanted to take this course, his course, Learn Tableau, this one right here, well worth your time. It is just a really good course. and it helped me to understand Tableau, like when I had like zero clue. What I did at the time, and I'll just put this out there with our last minute here, was I was just like, oh, I want to learn Tableau. And, this was the first course that came up. So this course right here, worth your time. If you have never taken a course, it's going to take you from having like zero understanding. You're going to download Tableau. You're actually going to do some projects and stuff like that. When you hear him, he'll switch from like this setup where he's talking to you, and then you'll kind of go back, and once you get done with the course, then you go to the part where he gives you a couple of things, like where you can download, but then you get then you'll get a certificate, and your certificate looks like this. And so as you can see, in December, I finished it with 9 total hours and stuff like that. So this was one of the first things that I popped up on my website to showcase that I had some experience with doing it. So to me, it was totally worth every cent that was paid in learning about Tableau. So don't let the price be a distractor for you. There are ways that you can do this where it's a monthly cost. This course, I don't believe, is included in their Udemy's like monthly, but that's that part. So loved Tableau. I appreciate you guys coming and hanging out and chilling with me and learning with me and that type of thing. We are going to go ahead and get out of here. I'm going to give you 5 minutes back to your Saturday. If you have any questions, anything that you want to know about, that I can do some research for you, by all means, you can find me on socials. You can even go to my email. Go to my website. That way you can at least find me. All right. So that is the end of the stream. I appreciate you guys being here. I will talk to you next week. We will meet on Monday, so we won't be meeting tomorrow. I need to redo this slide, but I'll be seeing you guys on Monday. Later.